we have a triangle. I'm just going to sketch this out. And we're told that each of the angles is a whole number of degrees. And one angle, let's say it's x, is 30 degrees larger than the average of the other two angles. Let's say they are y and z. So, okay, it's not drawn to scale or anything, but let's say that is x and y and z here. So that means that x is going to equal the average of y and z. So that is y plus z over 2. But it's 30 degrees larger, so I need to add 30 to it. And we've got an equation relating them. I can times through by 2 here, so I times both sides by 2, which essentially means I times each term by 2. 2x is equal to y plus z plus 60. Now we also know, of course, that x plus y plus z must equal 180 degrees. Therefore, I could actually rewrite the previous equation to make y plus z the subject, and then I can substitute in. That seems like a good idea. So y plus z must equal 2x minus 60. So I can now replace this by 2x minus 60, which gives me 3x minus 60 is 180, or 3x is 240. And therefore it must be that x is equal to 80 degrees. That makes sense, doesn't it? Because the remaining two would sum to 100, and if you find the average, you get to 50, and that is 30 less than 80. So this must be 80. We're asked for the largest possible size of an angle in this triangle. Now what we actually have left is 100 degrees to share between y and z. They have to both be a whole number of degrees, and so the largest possible would be to make one of them as small as possible, and that would be 1 degree, that's the smallest it can be. And then the remaining one, let's say z in this case, is going to be 99. So in fact, we can get an angle greater than 80 because the other one is so small that the average ends up being less. So the largest possible size of an angle is going to be 99 degrees.